Hey everybody, Doc Hydro here, December 21st, 2020. I want to wish everybody a Merry Christmas and a Happy New Year. Listen, got a couple of things I'm going to be going over right now. Well, I've got three things. The first one is about the new program that I'm trying to create, and that is called the Wildland Master Engineer. Now, in the structure world, we have apparatus engineers. The apparatus engineer is the single most important individual, second only from the incident commander on the scene or the battalion chief, uh, as far as the knowledge that is required to do the job. In other words, in the structure world, you got, especially in the cities, you got the guys that are going in with long hose lays. They're going up several flights into high-rise buildings and everything else. And you might have multiple nozzles going in through there. And you need a guy that really knows his stuff on the fire ground. Everything about pumps, everything about hydraulics. If the guy sits here and says, hey, look, this is what we're doing. We got to go another 300-400 feet. And then we got to go up another 150 feet. I need this much water. That engineer is going to sit here and in his head automatically that fast know what he needs to do and what resources he needs to make it happen. Okay, because remember, my motto is engineers make it happen. So having said that, the engineer, for those on the wildland fireground side, an engineer is a guy that solves problems. He's not the engine operator, which is typically what we have in the Federal Fire Service is engine operators. They're not engineers, even though that they're called engineers. There's a big, big difference. In the Federal Fire Service, and in some state services, but mainly the Federal Service, we train people in the wildland fire arena on how to drive apparatus safely off-road. Great. We teach them how to operate their pump. We teach them how to perform simple and then complex hose lays, but the complex hose lays are only progressive hose lays. So they're really not that complex. Anybody with a fair degree of even rudimentary instruction can perform those tasks. Okay, so it's not really complex, contrary to what some people might think. So how does this play into what I'm trying to get out? So here's where it is. Engineers solve problems, okay? They use tried, proven, scientific, mathematical procedures and processes, taking into account their own knowledge and abilities, their own training. They take into account the available resources that are currently on scene, manpower, needed manpower. They jumble all this stuff up, put it all together in their head, and spit it back out and say, this is what I need. You get me this, I can make that happen. But they also take it one step further because now they're doing it in rural America that doesn't have any of this stuff readily available. So that's largely the main difference between the structure world and the wildland fire world, which is structure world usually will have a lot of hydrants and a lot of water tenders and resources available at their fingertips, usually just minutes away. Whereas in rural Nevada, especially where I'm at, it's as much as a 2 to 4 hour turnaround just to get water, depending on where you're at. But the resources are still showing up. Helicopters are showing up, sometimes, oftentimes multiple helicopters. So you've got those guys, they usually have buckets. Then you got multiple engines, and all these people are going to be using water simultaneously. You've got to be able to plan for that and figure out what you need to make that show continuous and stay strong and working. That's where the Master Engineer program comes in, because you are the only individual, or if you go through my program, you will be the only individual on the fire ground that when everybody else is like, well, I don't know what we need to do, you will. And you'll be able to do it successfully every time. That's the catch. So, master. Let's talk about the term master for a minute. The term master is basically the main or the principal person in something. So you could be, out of everybody on the fire ground that understands things, you're going to be the main individual that they go and see. Okay. You can also be the one having, or the only one having, great skill and proficiency in something. Okay? You acquire complete knowledge or skill in the art or the science that you're working with. So again, the difference largely between the structure world and the wildland world, okay, those two different worlds is that the structure world will have, as a general rule, a lot of hydrants and water tenders and other apparatus or engines at their disposal. We don't have that per se in the wildland fire arena. We have to wait for hours sometimes to get them to show up, sometimes days if they got to come across the states. Okay, so even so, when they show up, typically what we see is that most engine operators don't know how to assemble all these things to take maximum advantage of the apparatus's capability. It's not a limitation on the apparatus. It's a limitation on the skill of the operator slash engineer of that apparatus. That's my goal, is to bring the apparatus operator or the engine operator up to a level to where nobody matches him on the fire ground. Now, that's where that is. So that's what I'm trying to do right now. I've got one individual that I signed a certificate and issued a certificate this past October to. And I was able, after the season, just a week or so ago, was able to talk to the individual and say, hey, so do I need to bump up my training? Do I need to basically rethink how I'm teaching, or was what I taught you good enough? And the response that I got back was actually pretty overwhelming, because I was told that what I had taught him gave him such a strategic tactical edge over everybody else that he was able to sit here and solve for the water delivery problems, because what's going out has to be matched by what's coming in. You've got two things. If the water coming out is not matched by what's going in, the operation fails. So that means he had to take care of multiple air resources. He had to solve the engine problem. He had to solve the water delivery problem. There was relay pumping. We're talking like 50,000 foot hose lays. Sounds pretty far-fetched. When I get him and then Jersey back on together, I tell you firsthand. So that's where that is. If you're interested in becoming a wildland master engineer, definitely look me up or get in touch with me, because it's not on the website right now. Think of what's on the website as a good primer. If you can get through that, that's good, but that's a primer to what you need to be able to do. So that's where that is. And then Zoom account. Wildland Apparatus Engineers now has a Zoom account, so I could be able to start doing virtual hydraulics classroom training. That was the purpose behind it, as well as webinars. So watch out for that, and emails and whatnot in the upcoming weeks. And then also social media. Wildland Apparatus Engineers is on MeWe.com. So look us up on MeWe.com. Outside of that, the only other thing that I've got right now is I've got one of the guys that I work with. He's the lead of our fuels crew. And he was saying that it would be a really good idea if I could put together a video about hose lace in the crew world. So that's going to be coming up, but I'm working on that. So anyway, guys, be safe. Have a good holiday season. And stay tuned for the upcoming videos. We'll catch you later. Bye-bye.